Hey, what's up everybody? This is Sean Wolslegel coming at you with another video. And in this video, we're going to talk about the networking that you need to know to succeed as a cybersecurity professional. This is going to be a continuation of our Cybersecurity Degree for Free series. This video is basically going to be what I wish I had known on day one in order to be job ready in cybersecurity, and what I used to do, which was system administration, and the things I wish I had been better at in order to be the best cybersecurity professional that I could be at the time. Now, I've learned all this over the years, so I'm giving all of this to you because I think that this will help you out in your career. And if you're able to know these terms and you're able to know these different devices and topologies that I'm about to go over, I think you'll be a shoo-in for success in your career. Without further ado, let's dive in. So let's start off with, what is a network? A network is when you have two or more devices, computers, smartphones, tablets, printers, anything that's connected together for the purpose of sharing resources and communicating with each other. Resources that you'll typically see being shared on a network include things like files, printers, and access to the internet for your devices. Devices on a network can also communicate with each other by sending and receiving messages. Networks are extremely important for you to know as a cybersecurity professional because they are one of your key areas whenever you are trying to protect against a cyber attack. Because of this, bad actors typically try to get into a network so that they can steal valuable data and information such as intellectual property and inject various types of malware to disrupt operations. And in some cases, you'll see it where they'll try to inject the malware first. And if they're injecting the malware first, they're trying to put it there as a seed so that way they can wait for the right time to strike. They're basically watching things. They might install a keylogger on a machine, and they're trying to see if they can come in and when the right time is to strike, knowing that they don't have any attention on them at all, and then they'll steal the data that way. Protecting your network is really important for that reason, because if you're monitoring your network, you're making sure that those bad actors aren't on there, and then that way they can't ever get in there and do anything malicious in the first place. If you have this good understanding of networks, you'll know the vulnerabilities that exist, and you'll have more attention and ability to protect your businesses from potential attacks in the future. Let's dive into the next topic, which is the types of networks that you'll see. The different types of networks that you'll see in order from smallest to largest. The first is a personal area network, or PAN. A PAN is the networking of personal devices such as computers, smartphones, tablets, anything that you would assume to be in close proximity to each other. You'll usually see a personal area network, or PAN, for sharing files, printers, and other resources. Some examples of this would be Bluetooth devices such as headsets, a game controller, wireless mice, a drawing tablet, or maybe a printer that is connected to a computer via a USB connection. The next item on our list is a local area network, or a LAN. A LAN is the networking of computers that are located in a relatively small area, such as a home, office, or school. LANs are typically used to share files, printers, and other resources as well to connect to the internet. This is the kind of network you expect to see in your house, the network in a school or public building, and the network in an office. LANs are going to be what you most commonly see when you're interacting with network architecture, and you also interact with WANs, which we'll get to in a minute, but definitely know a LAN like the back of your hand. The next type of network is a metropolitan area network, or MAN. A MAN is a type of network that covers a larger area than a LAN, but smaller than a WAN. A MAN is usually used to connect multiple LANs together, as well as to connect out to the internet. This is the type of networking that connects computers and infrastructure in a city, or the type of network that you typically see connecting computers, servers, and other infrastructure in a university or college campus. The last type of network that we see is a wide area network, or a WAN. A WAN is the type of network that covers large geographic areas, such as a country or even the whole world. WANs are usually used to connect multiple LANs and MANs together, as well as to connect out to the internet. Some good examples of this would be the internet itself is considered a WAN, or the network that connects a multitude of computers inside of a company's different offices that might be spread out geographically. If you think about a large corporation, name any large corporation, and they might have an office in, say, Minnesota, for example, India, China, and maybe some other country, Germany, just for example. All those different locations need to be connected somehow, so that's where a wide area network comes into play. Next, we're going to dive into topologies, or how things are connected together. The first is our simplest, which is a bus topology. In a bus topology, all devices are connected together using a single cable. This is the simplest topology of all, but it is oftentimes very difficult to troubleshoot if there is a problem with the cable that is connecting up the devices. You won't typically see these networks in your career because of things like data collisions, which is when two or more devices are attempting to transmit any data over the network at the same time. The fact that there is a limited number of devices that you can put on a bus network, and it's also very difficult to troubleshoot and track down the source of a problem in this type of network. The next type of topology that you'll see is a ring topology. In a ring topology, devices get connected together in a closed loop. Data travels around a loop in only one direction. And again, you likely won't see this type of topology in your career because there is always a single point of failure in this type of network. If any of the network devices in the ring fail, your entire network goes down too. And this is usually difficult to troubleshoot as well. It can take a long time for you to pinpoint exactly where a problem exists if the network is down, which will lead to downtime and disruption for your business. They're also difficult to expand on. Adding new devices to your ring networks will cause downtime for your network and disrupt the business again. The next is going to be probably the most common you're going to see in your career, and that is a star topology. In star-type networks, all the devices get connected up to a central location, usually a router or a switch. This is the most common topology you'll see in the field for a LAN when you're working in cybersecurity. These types of networks are very easy to troubleshoot, expand on, and they will provide good performance for a business. They're very reliable, which is why you'll see them most often. The next topology is a mesh topology. In mesh-style networks, you'll see devices connected to all the other devices. This type of network provides the best redundancy and fault tolerance you'll find in a network, but unfortunately, it's also the most expensive to set up as well. The costs on these types of networks has dropped dramatically over the last several years, and most households in the United States are adopting mesh networking at this point. Using this in a business setting in 2023 is ideal as long as your business can afford it. The next topology that you're going to see is a tree topology. A tree-style network combines the star and bus topologies. There is a central network hub, and all your devices and infrastructure are connected to each other in a star-style configuration. This topology is typically very easy to manage and expand on. The last topology that you'll see is a hybrid topology. A hybrid topology is when you have a combination of two or more of any of the mentioned topologies that I just went over. These types of networks are typically considered custom and are used to create networks that are desired by the specific goals of an organization. You may have to architect or review these types of networks on occasion as a cybersecurity professional. If you're a pen tester, you might run into these when you're trying to map out a network. Choosing the best network topology when you're designing or reviewing network architecture really depends on the intended size of that network and how many devices you'll plan on having or currently have, how reliable you want the network to be overall, and how much is in the organization's budget. Moving on, devices you'll commonly see in a network. Starting off with a hub. A hub is simply a device that connects multiple devices together on a network. It operates at the physical layer of the OSI model. You won't typically see these anymore because when a data packet is received at any port on a hub, the packet gets retransmitted to all the other ports on a hub. This means that all your connected devices will be receiving those data packets. Let's quickly talk about what a packet is for your future reference. A packet is a unit of data that is transmitted over any network. Packets are small, ranging in sizes from a few hundred bytes to a few thousand bytes. Back to hubs. The main advantage to hubs is that they are usually inexpensive and easy to set up. Switches have pretty much replaced hubs at this point because they are more efficient and offer better performance. So here are some instances where you might run into a hub still today in 2023. In someone's home network for the purpose of just simply connecting a few of their devices, such as their computers, their printers, and maybe some of their gaming systems. In a small office or classroom to connect a few computers and maybe a printer together, and maybe in a specialized scientific laboratory to connect a small number of scientific instruments. The next device is a switch, not like a Nintendo Switch. Not like a Nintendo Switch. A switch connects multiple devices together and then forwards packets to their intended device. It operates at the data link layer of the OSI model. When switches receive packets, they learn that particular device's MAC address for future reference. The intention here is that the switch will then always forward future packets to the intended destination from this point forward. Switches also support more advanced features than hubs, such as VLANs and QoS, which I'll talk about in a moment. Advantages include forwarding packets to the intended destination device rather than broadcasting them to all the devices on the network, which reduces your overall network traffic and improves performance. That's a huge advantage over what the hub was able to achieve. The next advantage is supports more advanced features than hubs, such as VLANs and quality of service. And they're also more reliable than hubs, as a switch failure will not take down your entire network. The main disadvantages to a switch is that they are more expensive than hubs and they're more complex to set up than a hub. Switches are used in a variety of networks, including home networks, small office, home office, or SOHO networks, and large enterprise networks. They are the most common type of network switching device in use today. You're also going to see managed switches and unmanaged switches. The big difference between a managed switch and an unmanaged switch is how much control your network admin has, which might be you. With a managed switch, the admin can set it up and keep an eye on how it's doing. But with an unmanaged switch, you just plug it in and it works. No additional setup needed. So this is the kind of switch that you would see in a home network, which would be an unmanaged switch. But in an enterprise setting, you want to have the managed switch. Here are some examples where switches might be used. In a home network to connect multiple devices, such as computers, printers, and game systems. In a small office to connect multiple computers, printers, and maybe some other devices as well, specific to that organization's needs. And in a data center to connect multiple servers and other devices. And maybe in a college campus network to connect multiple buildings together. The next device on our list is a modem. A modem is a device that connects your computer or network to the internet. It does this by converting digital signals from your computer into analog signals that can be transmitted over a phone line, cable line, or fiber optic cable. The modem then converts the analog signals back to digital signals when they are received from the internet. Modems are essential for most home and business networks. They are typically provided by your internet service provider or ISP when you sign up for internet service. Modems come in two main types, cable modems and DSL modems. Cable modems use cable TV lines to connect to the internet, while DSL modems use phone lines. Cable modems generally offer faster speeds than DSL modems, but unfortunately, they're still not available in all areas at this point. Here are some of the main benefits of using a modem. It gives you the ability to connect out to the internet. This gives you access to a vast amount of information and resources. It gives you fast speeds. Modems typically offer a large variety of speeds depending on your ISP and the type of modem that you get from them, which allows you to suit the speed that will best meet your needs. And then they're very easy to use. They don't require a lot of setup, and most of the time your ISP will just come in and do it for you. So here are some examples of where you might see a modem in your future. In a home network to connect your computers or your smart TVs to the internet. In a small office network to connect your computers, your servers, and your printers to the internet. And in a large enterprise network to be able to connect multiple buildings together out to the internet. The next device on our list is a router. A router is a device that connects two or more networks and enables them to communicate with each other. You can think of it like a friendly traffic cop for your network, which ensures that your data reaches its intended destination. Routers achieve this by using things called routing tables, which contain a list of all the networks the router is connected to and the best path for it to reach each network. Routers play a crucial role in connecting multiple devices to the internet and facilitating resource sharing, such as files and printers. Additionally, they enhance security by keeping different networks separate from each other. So let's explore some practical examples of how routers can be used. In a home network, a router might connect up your computers, your smartphones, your TVs, and maybe a couple game systems. In a small office network, a router will link your computers, your printers, and your servers out to the internet. And in a large enterprise network, you might see it where your buildings and your departments are able to talk to each other. And here are some benefits of using routers. With a router, you're going to get enhanced security because it allows you to isolate your network and prevents unauthorized access to data. And you're also going to get increased scalability, which will enable the connection of more networks, making them essential for a large enterprise. The next device on our list is an access point. An access point is a device that allows wireless devices to connect to a wired network. In your house, this is typically your router or modem. This means that you can use your laptop, your smartphone, or your tablet to connect out to the internet without having to plug in a cable. Access points, or what they're commonly called as APs, are typically connected to a router or switch using an Ethernet cable. Once connected, the AP can broadcast a Wi-Fi signal that wireless devices can connect to. APs are used in a variety of environments, including homes, offices, schools, and public places. They are essential for providing wireless access to all kinds of devices. Some of the benefits of using an AP includes convenience, because you don't need to be connected in, hardwired in. You're able to connect wirelessly. Performance, which means that you can have extended coverage over your building without having to run cables. And scalability, because it will accommodate more devices, and this is especially beneficial for large enterprises and organizations with numerous wireless devices. Some examples of where APs might be used is pretty much anywhere that you would want to have wireless internet access to help out your customers or for your family. Anywhere that you want to have Wi-Fi basically is where you can expect to have an AP. The next device on our list is a patch panel. A patch panel in networking is a handy tool that helps keep all your network cables organized and under control in your server room or in your network closet. It's usually mounted in the back of a network rack or cabinet and acts as a central hub for connecting and terminating all your network cables. Patch panels are typically made out of metal or plastic and have a lot of physical ports for you to be able to plug in all your network cables. These ports are usually labeled so you can easily figure out which cable goes where. Now, let's talk about why patch panels are great for networking. You'll get improved organization, which means that patch panels will help you out when it comes to keeping your network cables tidy and organized. This makes it a breeze to troubleshoot and maintain your network. You'll get increased flexibility, which means that you can easily add or remove devices from your network without any extra hassle. And this is perfect for businesses that are always growing and changing. And you also get reduced risk of damage because they will provide shielding for network cables, protecting them from potential damage. This means a more reliable network overall. The next device on our list is an Ethernet cable. An Ethernet cable is a type of cable that connects devices to a network. Ethernet cables are made of copper or fiber optic, and they come in a variety of lengths and colors. You'll regularly hear this in the real world as a patch cable rather than an Ethernet cable. These are composed of twisted pairs of data transfer cables. Twisted pair just means that the cables are literally twisted around each other to reduce electrical interference over longer distances. The next device is an RJ45 Jack. This is an 8-pin receptacle that you can use to plug in your patch or Ethernet cables. You typically crimp down your connections on this and run the cable through the wall back to a patch panel. Then the patch panel will connect to the switch or router. The next device on our list is a network rack. This is just a device that's used to house all of your networking equipment. You'll typically see them in a variety of sizes, and usually when you see those big blinking towers in networking closets or server rooms, that's what this is. You can usually stack servers and switches and routers all on top of each other in a single rack, and you can line them up next to each other. The next device on our list is a server. A server is like a special computer that stores and shares information. They're useful for storing files, websites, email, and all kinds of different data. Servers are very powerful because they can handle a ton of traffic and requests all at one time. You can find servers in a lot of places, such as businesses, schools, libraries, or you can even have one in your own house. Servers are what make the internet work, so you can easily access things like websites and all the great stuff that's available to us on the internet. The next device on our list is a firewall. A firewall is a security device that helps protect your computer or network from unauthorized access. It works by inspecting all the incoming and outgoing traffic and then blocking that traffic that does not meet the security rules that are configured for the firewall. Firewalls can be implemented as a hardware device, software which is virtualized, or a combination of both. Hardware firewalls are typically used in larger businesses and organizations, whereas software firewalls are usually seen in a house or a small business. Firewalls can be configured to allow or block traffic based on a variety of factors, such as the IP address of the source and destination, port numbers that the traffic is using, the type of traffic, whether that's web traffic or email traffic, or maybe some other type of traffic, and also based on time of day. Firewalls are also used to create virtual private networks, which will allow you to securely connect out to a remote network over the internet. Here's a friendly way to understand firewalls. If you can imagine a guard at an entrance, that guard's job is to check the IDs of people who want to enter the building that you work at and to make sure that they are allowed to come inside. The guard is also responsible for preventing people who are not allowed to enter that building. Firewalls are like this. They are an essential part of any network security strategy. They can help to protect your network from a wide range of threats, including things like bad actors, malware, denial of service or distributed denial of service, and phishing attacks. And you're typically going to see them in a home network, a business network, or somewhere in the cloud, such as AWS or Azure. There's also specialized firewalls called next-gen firewalls. A next-gen or next-generation firewall, also abbreviated as NGFW, is a type of firewall that provides advanced security features beyond your traditional firewall capabilities. Next-gen firewalls inspect traffic more deeply, going as far as the application layer to identify and block any malicious traffic they detect. Some key differences between next-gen firewalls and your traditional firewalls is that they have things like application awareness, which means that they're aware of the applications that are being used on your network, and this allows them to block malicious applications and traffic, even if they are using encrypted protocols, which is great. Intrusion prevention, which can detect and prevent common intrusion attacks, such as a SQL injection attack. Sandboxing, which will allow your firewall to sandbox any suspicious traffic and prevent it from harming your network. And threat intelligence, which allows your firewall to constantly get sourced from intelligence feeds and identify and block new and emerging threats. These feeds would typically come from organizations like Palo Alto Networks or Cisco or some other network like Juniper Networks. And so with these threat intelligence feeds, you're going to see the firewall constantly get smarter and stay up to date with the latest trends. These are commonly seen in larger enterprise networks, maybe some small business networks, and especially in cloud computing nowadays. Anywhere that you expect to see a way to protect the network in a more thorough detail, that is where you can expect to see next-gen firewalls replacing your older typical firewalls. The next device on our list is an IDS, or intrusion detection system. These are devices used for detecting intruders on a network. These devices look for anomalies on a network that do not look like typical network traffic. They also can involve signature-based scans, which are predefined checks from a company such as Cisco or Palo Alto or Juniper. Like I said, with the next-gen firewall, this is a feature built into next-gen firewall, so you get this added on as a bonus. The next device on our list is an intrusion prevention system, or IPS. These are devices used for preventing intruders from getting into a network. This does the same thing as an IDS essentially, except it will also take action to prevent it from happening in the first place, such as blocking traffic, dropping any incoming packets that look suspicious, and putting a suspicious device into a quarantine away from the rest of the network so it can't infect other devices. And again, this is also typically built into a next-gen firewall nowadays. So if you're getting a next-gen firewall, you're getting a firewall with this intrusion protection and with this intrusion prevention and intrusion detection built right into the device. Very useful. And the last type of device that we're going to talk about is a honeypot and a honeynet. A honeypot or a honeynet is a device or a cluster of devices that are used to look appealing to a bad actor so that they can be convinced it is a real asset to an organization to try and attack and steal data from. You can think of a financial system for a bank. If you put a honeypot in that network, you could mimic a real financial server without the real customer data in it, and then try to convince an attacker to take the bait, thereby catching the attacker in the act. You typically use these to know if you have a network breach on your hands, and you'll typically hear this called a deception-style technology. The next section is the terms you should know, starting off with one of my favorites, which is pots and pans. Pots and pans is just plain old telephone service and pretty awesome new stuff. The next term is a packet. Packets are small units of data that are transmitted over a network. They are typically a few hundred to a few thousand bytes in size, making them easier to transmit and less prone to corruption compared to a large block of data. And packets consist of two parts: headers and payloads. The header contains information such as a source and destination address, the type of data that's being carried, and then the packet's sequence number. This payload contains the actual data being transmitted. Packets are then sent over the network using various protocols such as TCP and UDP. TCP is commonly used for internet traffic, while UDP is typically used for streaming media and gaming. As a packet travels over a network, they pass through multiple devices like routers and switches. Each device reads that packet's header to determine where it needs to go next. Packets are vital for the overall function of the internet because they enable efficient data transmission over long distances. The next term on our list is a virtual LAN or VLAN. You can think of a VLAN as a group of devices on a network, but in a much more organized way. VLANs help split up a network into different areas, which makes things work better, be more secure, and easier to handle overall. VLANs are made using switches. Each switch port can be assigned to a VLAN. When a device is plugged into a switch port, it joins the VLAN assigned to that port. VLANs are used to group devices together based on a lot of different factors like what department they're in, what they do, or how secure they need to be. For example, a company might make a VLAN for marketing and another VLAN for engineers, and maybe a third VLAN for guests. VLANs can also boost performance. For instance, a company might have one VLAN just for their servers and another VLAN for their workstations. This way, server traffic won't slow down the workstation traffic by hogging all the bandwidth. VLANs also help to make things more secure for your network. For instance, a company might create a VLAN for its secret data and another VLAN for its maybe not so secret data. This way, only the necessary people have access to that secret data and not just anybody. So some of the major benefits of using VLANs is that you get enhanced performance, enhanced security, and enhanced manageability. You're going to see VLANs all the time in your career, and especially when you're working in a corporate network, you're going to see them a lot. The next term that we're going to go over is subnets. A subnet is a smaller part of a larger network. You can think of it like dividing a big pizza into smaller slices. Each slice is still part of the bigger pizza, but it's easier to eat and manage on its own. Subnets are created using a subnet mask. A subnet mask is a specialized number that tells a network which part of the IP address is the network address and which part is the host address. The network address identifies the subnet, and the host address identifies the individual device on the subnet. Subnetting is used to improve the performance and security of networks. By dividing a network into subnets, you can reduce the amount of traffic that is broadcast over the network. This can improve the performance of your network and reduce congestion overall, and it can also be used to improve security by isolating different subnets from each other. This can greatly prevent unauthorized access to data on one subnet from accessing it on another subnet. If you can imagine a building with a large theater, the theater might be divided into 3 different sections, such as a small section, a medium-sized section, and a really large section. Each section is just like our subnets. The people in each section only see and interact with those other people in their own section. which helps reduce the amount of noise and confusion happening in that great big theater. Some examples of how you're going to see subnets is if you want to use it in your home, you might have a separation of your family's devices and maybe something for your guests. In a small office, you're going to keep your printers separated from your computers. And in a large enterprise, you might see it where you create a subnet for each separate department so that way one department can't see what the other department is working on, which will improve the security of your network and make it easier to manage overall. One of the things that really confused me when I first got in was, when do I use a VLAN and when should I use a subnet? Because they sound like the same thing. And so let's break that down. A VLAN and a subnet are both logical subdivisions of a network, but there's a difference in that they operate at different layers of the OSI model. A VLAN is a layer 2 device and a subnet is a layer 3 device. Since they're both logical subgroups, why should you use one over the other? VLANs are typically used for isolating devices based on their MAC address, and a subnet is typically used for boosting your network's performance and overall security posture by dividing that larger network into smaller separated segments. VLANs are created on switches and subnets are created on routers. Some example use cases where you're going to want to create a VLAN instead of a subnet would be if you're trying to increase your security and performance. VLANs will help you in isolating guest traffic from your employee traffic. This will ensure that your guest network remains separate from your internal network, which will reduce the risk of unauthorized access and potential security breaches. You might want to create a VLAN if you're going to optimize your voice calls, because VLANs are better at isolating voice traffic from data traffic than a subnet. And you would probably want to use a VLAN when you're trying to improve your overall performance and security. You would create a dedicated VLAN for your servers. Some example cases where you might want to create a subnet instead of a VLAN would be when you want simpler security, because subnets isolate traffic at the network layer. This is considered more secure than isolating traffic based on a MAC address, because MAC addresses can be easily spoofed. When you want to create a very large number of networks, subnets are going to win out over VLANs because a switch can usually only support so many VLANs at one time. And when you want to connect two different networks, you're going to use a subnet over a VLAN. You'll also use it whenever you want to create a DMZ or a demilitarized zone, which I'll talk about in a minute. And lastly, you're going to want to try to create a subnet instead of a VLAN whenever you're trying to implement quality of service, or typically called QoS, which is a set of techniques that can be used to prioritize traffic on a network. Subnets and VLANs can be confusing, but if you can keep them straight in your mind, you'll be doing really great in networking right from the get-go. In my next video, we're going to talk about how to subnet and the best way to do that on the fly, because subnetting is usually one of the things that confuses networking professionals the most whenever they first get started in this career field. So as a cybersecurity professional, knowing how to subnet will certainly make you a great asset in addition to a team anywhere you end up working at. The next term on our list is quality of service, or QoS. QoS is a set of technologies that can be used to boost the performance of your networks. QoS works by giving priority to your traffic on the network to make sure that important applications get the bandwidth and the speed that they need to be able to work well. QoS is important because it helps ensure that all your applications on your network can perform well, even when the network is congested. This is especially crucial for your applications that need real-time performance, such as voice over IP or VoIP and video streaming. QoS works by giving prioritization to the network traffic that needs it most, reservation, which is where you can reserve bandwidth for a specific application or certain traffic flows, such as voice over IP, and allows shaping, which is whenever you limit the bandwidth available to specific applications or flows. This will prevent certain types of traffic from taking up all the bandwidth on the network. In a business network, you're typically going to see QoS used to prioritize your voice over IP and your video conferencing apps, such as Zoom or Microsoft Teams. And so you'll typically want to use quality of service whenever you can to go ahead and make sure that your network isn't getting congested all at one time. The next term on our list is a DMZ, or a demilitarized zone. A DMZ is a network that is isolated from other networks. It's often used to host publicly accessible servers, such as a web server, a mail server, or maybe even a DNS server. And DMZs are separated from the rest of your network by a firewall. You usually create these rules at the firewall. The firewall allows only certain types of traffic to flow between the DMZ and the rest of your network, and this helps to protect the rest of your network from attacks. If you can imagine a castle with a moat around it, the castle would be like your internal network, and the moat is the DMZ. The moat makes sure that attackers can't reach the castle. DMZs will improve your overall security, your performance, and reduce your risk if you use them the right way. Some examples of where you would want to use a DMZ would be for things like a web server, a mail server, DNS, VPNs, FTP, and maybe in some instances at your house, if you play a lot of video games, you might have it there as well. The next term on our list is IP addresses. IP addresses you can think of like a mailing address for your devices on your network. An IP address is a unique number that's used to identify a computer or a device so that other devices can send information to it. IP addresses are made up of 4 numbers, each of which can range from 0 to 255. These 4 numbers are separated by periods called octets, such as 192.168.1.1. We don't call them periods, we call them dot. Every device on the internet has its own IP address, including your computer, your smartphone, your tablets, and your smart TVs, your video game systems. Anything that you use that's connected up to the internet has an IP address. When you want to visit a website, your computer sends a request to a web server, and that web server then sends the requested web page back to your computer. The IP address of your computer and the web server are used to route that traffic between both of the devices. And the last term on our list is a MAC address. A MAC address, or a media access control address, is essentially a fancy way of saying it is a unique identifier to your actual hardware or your network interface controller in your devices. A network interface controller, also called a NIC, is a piece of hardware that lets your device connect out to the network. MAC addresses are made up of 6 hexadecimal digits, such as 00-11-22-33-44-55, although you're probably not going to see it that simple. So why do we even care about MAC addresses? They're like secret codes that allow you to locate your devices on a network. Whenever a device sends data over a network, it puts the MAC address in the data packet. That way the network knows exactly where to send the data to in the future. MAC addresses also play a role in security by allowing you to filter based on MAC address, although you can spoof a MAC address. With MAC address filtering, you get to decide which devices are secure enough to connect to your network. It is handy for being able to locate devices. Just essentially know that a MAC address is what your network says, okay, I know this device on the network is a MacBook. Okay, I know what this device on this network is an iPhone. If it knows that, it's able to tell what type of device is what. In the next video, we're going to be talking much more deeply about IP addresses, MAC addresses, network gateways, how to subnet, and how we can use all this information as a cybersecurity professional. It's going to be a lot more in detail, and we're going to talk about networking math and how we can take all of that and use it to the best of our abilities as cybersecurity professionals and to be able to do our jobs in the best way that we can possibly do them. So thanks for watching this video, and I appreciate your time, and I hope you have a wonderful night, and I look forward to seeing you again in the next one.